Hi everyone, am I audible right now? Just let me know if I'm audible. I guess the PCDs have had some off timing, like after 5 hours of the contest, so there are less viewers. Actually, it was prohibited to discuss the problem set, right? Like they had said that it is forbidden to discuss the problems publicly until the end of on-site round. That is 3 hours after the end of the CF round. So we had to delay the PCD. But anyways, so I guess comparatively less people are there. So if anybody is here, can you all hear me? Okay. So hi everyone. My name is Pradyumn and today we'll discuss the today's CF round that was 1069 div 2 and we will be solving the problems A to D. But before we begin, I'll tell you about our courses at TLE Eliminators. So if you are someone who is trying to level up in CP and you are stuck at just solving one or two problems per contest, then our self-paced courses are exactly what you need. We have structured the program into four levels, so you can start from wherever you are: beginner, pre intermediate, intermediate, or advanced. You will learn the most relevant CP concepts through video lectures, followed by carefully select practice problems, combined with guided hints and video solutions that help you understand the why and not just the how. We believe in helping you build real intuition. And beyond learning, you can enjoy leaderboards, progress tracking, internal contests, and PCDs to keep you consistent. Pick the level that fits your goals and start learning today. And if you are not sure that which level you should pick, then you can watch this video, which tells you about how to choose a level. It's not loading right now, uh, but you can go to this website and you can watch the video, which would appear right here. I guess my home internet is not that good. And if you are still not sure, then you can go to the course page and watch this video, which will appear right here. It will explain more about the syllabus, prerequisites, and all, and outcomes. All right. So I think that's it. Let's start with the PCD now. Okay. So the problem, first problem of div 2 was this, not this one. It was this. So the problem was little fairies painting. The little fairy has a ribbon with 10 to the power 18 cells and an infinite variety of colors. The first n cells of the ribbon have already been colored, where the ith cell is colored with color AI. Little fairy will color the remaining cells in order from n plus 1 to 10 to the power 18. For the ith cell, little fairy first counts the number of distinct colors present on the ribbon, denoted Ci. Then she will color the ith cell with color Ci. What is the color of the 10 to the power 18 cell? Okay. So what they are saying is that we have a ribbon, right? We have a ribbon which is initially uncolored. Okay. Like okay, initially it is not uncolored. It is colored with only first n cells. Like only the first n cells have been colored, and the remaining cells. Actually, there are 10 to the power 18 cells in this ribbon. It is a very long ribbon. Okay. So there are 10 to the power 18 cells in this ribbon, and they have not been colored yet. Only the first n have been colored, right? And they have given you that what is the color that she has colored with. Okay, like they have given you an array of length n. So a of I denotes the color of the ith cell. Okay, in the input. All right. So now what she does is she will take a look at all the colored cells and see that how many distinct colors are there, how many different colors are there. Okay, and that is the color she will fill here. All right. and she will keep doing this. Like let's say she has colored this now, so now these cells are colored, right? So she will look at them and look at the number of distinct colors, and then she will fill that right here, and then she will look at these, and then she will fill this, right? So we have to find out that what is the color of the 10 to the power 18th cell. Okay, so how would we solve this? Like let's do some examples. I think it will be pretty clear to I think it would be pretty clear how to solve this if you just look at some examples. Okay. So the first example is 1 1 1 1 1 1. There are six ones. Okay. So 1 1 1 1 1 1. Right. So first she looks at what is the distinct number of colors present on this strip right now. So only one color is there, one, right? So she will append one, right? Now she will look at this. So now also only one is present. So she will append one again. Now she will look at this. Only one is present. So she'll append one, and so on. So um, repeatedly, one would be added until she reaches 10 to the power 18th cell, right? So 10 to the power 18 times one would be added, and so final color of the 10 to the power 18 cell would be one, right? Now let's say we have this test case. Or let's say we have this test case. Okay, 44 1, 40, 4 1, 95, 8, 40. Right. So first of all, she counts the number of distinct colors in this. So there are six distinct colors, right? One, two, three, four, five, six, and they're all distinct. So she will append six to the end of this, right? So now again she counts. So 1, 2, 3, 4, 5, 6, 7, right? So she inserts 7 now. Now again she counts 1, 2, 3, 4, 5, 6, 7, 8, right? So now she'll append 8. Okay. Now again she counts 1, 2, 3, 4, 5, 6, 7, 8, 9. But this 8 it has come twice. So number of distinct colors is only 8. Like total number of colors are 9, but distinct there are only 8, right? So she'll append 8 again, and again she will count that there are 8 colors, so she will append 8 again, and again append 8, and so on, right? So the last color would be 8, right? So just by looking at this pattern, I think you would be able to answer that what happens in the general case. Like generally, let's say if you have a1 a2 a1 a2 a3 up to an, right, in the initial array. Now let's say that there are k distinct colors in this array, right? So what can we say? We can say that she will insert k, right? Okay. But now let's say she does the operation one more time. Like okay, she did it one time, she added k. Now she will do it one more time. So again she will count the number of distinct elements in this. So we know that number of distinct elements in this part is k, right? So if we insert this k number, so now what is the number of distinct elements in this whole part? You will say k plus 1, right? So it is k plus 1 if this k is new, right? If this k hasn't appeared before in this array, then it would be k plus 1. Like the number of elements, like if I give an example, let's say 1, 2, 4, 2, 4, right? So initially there are three distinct elements. Like in these five elements, there are three distinct elements, right? But so you add 3 now. So now initially it was 3, but after adding this number, now it is 4. That is 3 plus 1. Because this 3 got extra. But let's say that initially in the array there was a 3. Like let's say it was 1, 2, 3, 2, 3. Right. So initially there are like 3 different numbers. And now if you insert this right here, now also it has 3 distinct numbers. Okay. That's the thing. Like initially it is also 3, and finally if you insert this number, Now also it is 3 because this 3 was present already in the array. So if this k was present in the array, then it would remain k only. Like this whole part's answer would remain k. Otherwise, it would become k plus 1, right? So let's say if it is k only, then in the next step also you would insert k, and still it is k only because this k already has appeared before. So again you will insert k, and so on. Like you will keep inserting k, right? So if this k already appeared in the array, then you will keep inserting k. But what if it's k plus 1? Like if a1, a2 up to an, in this there are k distinct elements, and this k is not there in the array, so you will insert this, right? So now there are k plus 1 distinct elements, right? So now you will insert k plus 1, right? So after inserting k plus 1, what would happen? If this k plus 1 was already in this array, then you would say that the number of distinct elements, like if it was already there, then again it remains k plus 1 only, and you will insert k plus 1 again, and it goes on. But if this k plus 1 was not there in these elements, then you would then the count would become k plus 2, and you would insert k plus 2 here, and so on it goes on. So like basically as soon as you find a number which is there in this array, then you can say that that number would be the one that stays. Like for example here in this example, 44 1, 44 1, 95 840. Okay, actually 40 was there twice, my bad. I told you how here 6 would come, then 7 would come. Actually first 5 would come, okay, because there are only 5 different elements. So 5 would come, and now there are six different elements. So 6 would come, then 7 would come, then 8. All right. So yeah, my point is that okay, 44 1, 95 8, and 40, right? So first you will insert 5. Now since 5 is not there in this array, the elements become 6. So you will insert 6. Now 6 is also not there in this array, so it becomes 7. Then 7 is also not there, so it becomes 8. But 8 is there. 8 is there, right? So 8 will keep going on until 10 to the power 18, right? So 8 is our answer. Okay. So basically, whatever is the initial number of elements, k, like initial number of distinct elements, k, we just want to find out that what is the next bigger number in the array, right? Like here k was equal to 5, right? So we just found out that what is the next bigger element after 5? It is 8. So 8 is our answer, right? So we can simply use a set to find out the number of different elements, and in that set we can find the lower bound of that k. Like in this set, if we find the lower bound of 5, it turns out to be 8, right? Lower bound means the smallest number greater than equal to k. Okay, so that's what we can do. Like basically just find out the number of additional elements k in the array, and just find out that what is the next higher number after that k, right? So I think this should be pretty clear. If you're asking me, then I don't use GPT. Yeah, so just use set to find the number of distinct elements and just find the lower bound of that. So the answer is the lower bound of k. Okay. So I'll show the code. Uh, Wait, this is code for B, and this is also okay. Sorry, this was code for C. So this is code for A. Int n, C in n, make a set and insert the elements into that set, and print s dot lower bound of s dot size. So s dot size is the number of distinct elements, and you will find the lower bound of that value in that set. Okay, so I hope it is clear. I think it should be clear. Should I move on? Just write a yes in the chat. Okay, so problem B now. So B was called XOR array. You are given three integers n, l, and r. So in the input you have these three integers n, l, and r. You need to generate any array A of positive integers of length n. Let f of xy for 1 less than equal to x less than equal to y less than equal to n be the bitwise XOR. Be the bitwise XOR value ax XOR ax plus 1 XOR up to ay. So basically fxy is the XOR of the subarray ax to ay, right? Oh wait, yeah, you need to make sure that in your array you have to make an array in which fxy is equal to 0 for x equal to n and y equal to r. So f of l comma r should be equal to 0. Otherwise, it should be not 0. Like for all the other values, it should be not 0. So what they are saying is that we want to make an array, right? Such that they have given like two numbers l and r. So we have to ensure that the XOR of this subarray from L to R, this is L, this is R. So XOR from the of the subarray from L to R has to be 0, and XOR of any other subarray that you choose, like there are total n into n plus 1 by 2 subarrays, right? So out of them, the only this one L to R has to have 0 XOR, and all the other ones, that is n into n plus 1 by 2 minus 1, these many subarrays have to have non-zero XOR. Okay. So like for example, they have given the arrays, like they have given the test case 313, or let's say 413. So we have to make an array of length 4 where L equals to 1, R equals to 3. So like you have four numbers, and let's say like they printed 2754. Okay, 2754. So L equals 1, R equals to 3. If you see that 2 XOR 7 XOR 5, like basically the XOR of this subarray, it turns out to be 0. Okay, because 0 1 0, then 1 1 1, and 1 0 1, this XOR is 0. Okay, and otherwise, like if you take any subarray, basically one length subarray is also non-zero, obviously. Then two length subarrays, 2 XOR 7 is not 0, 7 XOR 5 is not 0, 5 XOR 4 is not 0. Then three length, okay, this one is 0 because it had to be 0. This one is not 0. 7 XOR 5 XOR 4 is not 0. Then um, this 4 length subarray is also not 0. So I just showed you that all these subarrays have non-zero XOR except for this subarray, which was what was needed in the question. All right. So there might be multiple ways to solve this. Like you might have came up with a nice construction. Like you might have used a lot of your brain to come up with a construction using bitwise tricks, like setting some bit as 1, some bit as 0, or so on. You might have done that, but I have a much brainless solution. Like there is no thinking required in that, so I prefer that solution. So my solution is that, okay, they have given, we have to make an array, right? We have to make this array, which is, let's say, I'll do it in zero based indexing, okay? Or okay, let's do it one based, a1, a2, a3 up to an, right? We have to make this array in such a way that f of xy should be 0 if x is equal to L and y is equal to R, right? And what is f of xy? F of xy they have defined as the XOR from x to y. So ax XOR a of x plus 1 XOR a of x plus 2 up to a of y, right? So f of xy is this. Now, what I can actually do is, like, see, whenever we are dealing with range XOR or range sum, let's say, like whenever you are dealing with range sum, okay, like ax plus 1 up to ay, okay, then you should think about prefix sums, right? But here we have XOR. Here we have range XOR, like XOR of a subarray. So we can think about prefix XOR. Okay. So define the prefix XOR array. Like let's say we have a1 to an. So I will define my prefix XOR array like this. That okay. If my array is a1, a2, a3 up to an, then my p0 would be 0, p1 would be a1, p2 would be a1 XOR a2, p3 would be a1 XOR a2 XOR a3, and up to pn. So pn would be a1 XOR a2 XOR a3 up to XOR an, right? So this is how I define my prefix XOR array to be, okay, this n plus 1 length array. And so I can actually write my fxy in terms of this, right? Like my fxy is what? Fxy is defined to be a of x XOR a of x plus 1 XOR up to a of y, right? So actually what we can do is just take the terms till y, like from a1 to ay. So what is that? The prefix XOR of y, right? And then just cancel out the terms. Like basically what is prefix XOR of y? Py is a1 XOR a2 up to XOR ay, right? But actually we want from ax only, not from a1. So we will cancel out the terms from a1, a2 up to a of x minus 1. So we'll cancel out these ones. So only ax and onwards the terms will remain. So what we will try to do is we will try to cancel out with p of x minus 1. Like we have this py which is 1 to x, sorry, 1 to y, and we'll have this p of x minus 1 which is 1, 2 up to x minus 1. So if we just like subtract them, or py XOR p of x minus 1, if we py XOR p of x minus 1, then we will get ax plus 1 XOR ay, right, which is f of xy. Okay, so this is what we get, that f of xy is p of y XOR p of x plus 1. Okay, I'll write this again, that f of xy is p of y XOR p of x plus 1. I mean x minus 1, sorry. Okay. Now what we want is, we want this to be equal to 0 if x equals to L and y equals to R. And we want this to not be equal to 0 otherwise. Right? Like basically we want that p of y XOR p of x minus 1 should be equal to 0 if x equals to L and y equals to R. And we want this to not be equal to 0 otherwise. Like I just wrote the same thing, but okay. So now can you guys tell me what to do? Like actually I can write this, or okay, I'll ask you guys. Can you tell me what to do? Basically this py and ph plus 1, I mean py and p of x minus 1, they are just numbers, right? Py is a number and this is a number. So what I can write here is that my p of y should be equal to p of x minus 1 if x is equal to L and y equals to R. And it should not be like, and I can write this as p of y should not be equal to p of x minus 1 if like otherwise, right? Like, when is p of y, when is x XOR y equal to 0? When x equals to y, right? So if py XOR p of x minus 1 is 0, then that means py should be equal to p of x minus 1, right? So I want that in my prefix XOR array, like I have this array, right? P0, P1, P2 up to Pn, right? In this array, in my prefix XOR array, I should have p of y equal to p of x minus 1 only if is equal to L and y is equal to R. That is, I just want that the values of my PR and p of L minus 1 should be same, right? Like R and L are two numbers that are given in the input, right? So I want that these two numbers should be same and all the other numbers should be different, right? For example, I have here in this input, let's say 4, 1 and 3. Okay. So I have n equals to 4 and L equals to 1, R equals to 3. Okay. So I just want that my P of 0 should be equal to P of 3. Why? Because when I find out A1 XOR A2 XOR A3, this is equal to P3 XOR P0, right? And I want that to be equal to 0. So I want that P3 should be equal to P0, right? And I want that the other items should not be equal to 0. Like, I want that all the other sub arrays should not be equal to 0. So that means I want all Px to be not equal to Py except for 0 and 3, right? So what I can do, like if I want to make the prefix XOR array, like the main idea here is I am making the prefix XOR array and not the actual array, right? So P0, P1, P2, P3, and P4. So here I want P0 equal to P3. So I can insert any element here, let's say 5. So I insert 5 here. And in the other elements, I want that none should be the same. So basically, let's say 1, 2, and 3, right? So this prefix XOR array, like, okay, actually P0 is always 0, right? Here I defined that P0 is always 0. So I cannot have that as 5. Okay, so I'll keep it 0. Okay. So my P0 would be 0. So P3 also is 0 because I want P0 equal to P3. And all the other elements I can assign randomly, but they have to be different from each other and different from 0 as well. So this prefix XOR array would satisfy. And since we have the prefix XOR array, actually we can find out the actual array as well. Like if I know the values of P0, P1, P2, P3, and P4, then I can find out the values of A1, A2, A3, and A4 as well. How? See, from here, what you can see, let's say if you take P3, let's say, like basically if you want the value of A3, then you can simply take P3 and subtract P2 from it. So P3 XOR P3, sorry, P3 XOR P2, right? That would give you A3. So in general, you can get AI as Pi XOR P of I minus 1, right? So if you have this prefix XOR array, P0, P1, P2, P3, P4, then you can get this like final array as P1 XOR P0, P2 XOR P1, P3 XOR P2, and P4 XOR P3, right? So if I just calculate that, this is 1, then this is 3, then this is 2, and this is 3. Okay. So this is how you can find the answer. How we think prefix XOR, basically whenever you have uh, the range XOR or range sum. Like here we had range XOR, right? Like ax XOR ax plus 1 XOR ay. So you have a range XOR, that is the XOR of some range. You can think about prefix XOR because you can simply write this as the XOR of two prefix values. Like whenever you have range sum or range XOR or range multiplication, you can think about the prefix. Okay. Uh, I don't get your question. Is it clear now? How come I thought reverse? Like whenever you see range, you think about XOR. Like sorry, you think about prefix. So um, prefix, if you think about that, then after that it is very natural. All right. So I think there are no doubts. I'll show the code. Meanwhile, if you have some doubts, then you can ask. So here is the simple code. Int nlr, seen nlr. Uh, then I have this prefix array which I will create. Right? It's of length n plus 1, 0 to n. So prefix of 0 equal to 0. Now from int I equal to 1, I less than equal to n, I plus plus. So what I am doing here is I want to fill p0 to, I want to make sure that they are distinct, right? P0, P1, P2, P3, P4, P5, and P6. So let's say if L is this and R is this. So I want that P1 should be equal to P5 and the rest are different. So what I am doing is I am just assigning Pi equal to I. Okay, so 0, 1, 2, 3, 4, 5, 6. And then I am just changing this PR to P of L minus 1. Like here, I want these to be equal, right? So I'm just changing this PR to be P of L minus 1. Okay. So int I equal to 1, I less than equal to 1, I plus plus. If I equals to R, then I will set PR of I equals to PR of L minus 1. Otherwise, I'll set it equal to I. Right. Um, and then just see out the array, that is A of I. So A of I is just like PR of I plus 1. That is, let's say, actually the I is starting from 0, right? I starts from 0. So I'll print PR of I plus 1, XOR PR of I. And actually this can be done in one line also. I'll try to do that. Let's see. Like int nlr, seen nlr, and cout. Let's use I equals to r minus 1, or yeah, then we'll print then what will we print? We'll print L minus 1 XOR um, I minus 1, right? Otherwise we'll print I XOR I minus I plus 1 XOR I. So here I think it should be I only. L minus 1 XOR I, right? So I don't know why I'm doing this, just to flex, I guess. Let's try this if it will work. Okay, it seems to be working. I think it is working. Let's submit this. Yeah, meanwhile, you can ask doubts. Maybe that is my defense, that I'm giving you time to ask any doubts if you have. But yeah, should work. Okay, actually, I plus 1. Maybe there is some issue with precedence, L minus 1. Or I'm just dumb. Okay, I'm just dumb. Never mind. Like, do I see the mistake? Okay, you don't. Never mind. Let's leave this. Let's move on to C now. So C, yeah, C was actually easier. Like I thought B and C are equally easy, but anyways. So this was C. You got lucky to know the answer to all important questions in the world. This time, the answer is the string S, consisting of lowercase English letter only, and you want to hide this string. You have another string T, also containing lowercase letters only. You need to shuffle the letters in T so that so that the string S appears at least once in T as a subsequence. Among all possible reorderings of T, find the smallest one. Okay, so like what they are saying is we have two strings S and T. Okay, and we want to rearrange this T. Okay, rearrange T so that S appears as a subsequence of T. Okay, that is the problem, and we have to find out the smallest possible T. Okay, that's the problem. That let's say we have this test case right here, DCBE, like S is DCBE. So we want this to be our subsequence, and we have this string T, and the string T is BED, BAE, CFC, BED, BAE, CFC. All right, and we want to rearrange this string T such that DCBE comes inside this string T, right? So let's say if I just rearrange this like this, DCBE. Okay, so DCBE is gone. Then let's say we have A, C, E, and FF. So this is one possible rearrangement of T such that this DCBE comes as a subsequence. So DCBE subsequence, right? And like it doesn't need to be contiguous, right? You can also have DC, like you can also have this DCABE, CEFF. So here A is coming in between, but this DCBE subsequence is subsequence, right? But um, the thing is that it is not the smallest. Okay, It's not the smallest because we can have A also in the beginning. Like let's say we have A, B, C, B, E, and C, E, F, F. So this string is also valid, right? Because it has D, C, B, E, but it starts with A, and this one starts with D. So definitely this one is smaller. This one is smaller, right? So therefore this is not the answer. Also, this is also not the answer because we can get smaller than that also. Like we can potentially have this C in the beginning. So instead of AD, we can have AC. So AC, then we can have uh, DCBE, and then we can have EFF, right? That is also one way. So maybe this is the correct answer. Like I don't know if you can get smaller than that. So is this the answer? AC, DC, A. Okay, you can get B also. Ah, right. You can get B also. How? Okay, because there are two B's. Right. Somewhere in between, I ate one of the B's. Okay. I thought this was an F. My bad. I thought this was an F, so I wrote this as an F, but it was B. Okay. So it was B. Yeah. So this is one of the possible things, but actually you can get smaller than that also because you can get uh, A B also here. Then you can have D C, then B, then E E F. Okay. So A B D C, A B C D C. You can have C as well here. Not, but yeah, you get the point. Like you have to rearrange this T. You have to rearrange the T such that S is a subsequence of T, right? And T is the minimum possible. Okay. So how do you actually do that? Now it is a very easy problem. Sorry if that was loud. Like my laptop started malfunctioning. But yeah, so what I was saying is you can simply do it greedily. Like what does this term mean? This means that you want the first letter to be as small as possible, right? Like you saw that one option that we had was this DCABE CEFB, and one option was starting with A. So since one starts with A and one starts with D, so this one is smaller, right? So we want that whatever is at the first position has to be the smallest, right? Like when we are raising T, we had this T right here. So I'll write in capital, okay, to make it easier. So BED, BAE, CFC, BAE, CFC, right? So we will make this rearrange this string, right? And it will become a 9-letter string. Okay. So we want that in the first place, whatever we put in the first place, it has to be the smallest possible, right? So now in our string T, what is the smallest that we have? Like the smallest that we have is A, right? So we want that A should be here. Like if it is possible, then A should be here. Like possible का मतलब क्या है? कि if using these elements, I mean if there is some string that starts with an A and has S as subsequence, then um, I should choose this A only. Okay. Like what is our S? Our S is DCBE, right? So um, I want A here, right? So I would put A here. If it is possible to create a string which starts with A and which contains this DCBE as a subsequence, right? So basically, I want to put DCBE somewhere in here, and if I put A right here, so is it possible? I mean, yeah, it is possible. Why not? Like just put DCBE, something like this, because you have enough characters, right? You have a D as well, you have a C as well, you have a B as well, and you have a E as well. So you can simply put them like this. So definitely, putting A is possible, right? Then in the next position, okay, so A is used up now. Now in the next position, what is possible? Like the smallest element is what? B. We don't have any A's left. All we have is B. So can I put B here? Can I put B here? Yes, I can put B here. Why? Because in the remaining string, I can make DCBE. I can simply place, because I have D, I have C, I have this B and this E as well. Like even if I don't have this B, I have this B. So I can definitely make DCBE. So I can place a B right here. That's possible. Okay. Now in the third element, here can I place this B? If I place this B right here, then is it possible? So the answer is no. It's not possible to make this DCBE because um, you want to make this entire DCBE right here, right? But you have no more B's left. So how can you make DCBE now? Okay. So you cannot really put this B here. You can't really put this B here. Okay. So let's say you try C now. So can you put C here? Yes, you can put C because you would still have D, C, B, and E for these positions, right? So you will put C here. So you have put C here, and you will cancel out this C. Then again you have one more C, but you cannot put it. Why? Because then how will you make DCB here? You can't, because there are no more C's left, right? So you can't put C here, but you can put D here. Okay. If you put D here, actually you have a B as well, right? Why did I look at C? You have a B as well. Okay, wait, what was the answer? A B, yeah, okay. You have B as well, but you can't put B here. Why? Because in that case, you can't make DCBE, right? Also, you cannot put C here because you won't be able to have DCBE here. But you can put D here. Why? Because if you cancel out this D, then actually you have already placed the first letter of string S. Like you have placed the D right here, right? So now all you need is a CBE in this remaining portion, right? And you have CBE, you have C, you have B, and you have E. So that's why you can actually put D here. That is fine. Okay. So you put D here and then you move on. So in this letter, now what you will try to do? You will try to put E. I mean, sorry, you will try to put B because this smallest letter it is. So you will try to put B, but can you put B? No, right? Because then you have to make B CBE here, right? CBE, but you can't because you have no more B's. So you will try C next. So can you place C here? Yes, you can, because you will cancel out this C, and you have placed this C also. So now you have made DC, and now you just need to make BE right here, BE, right? And you have B and E. You have enough BEs to make, right? So that's how you can simply make this string one by one. Like at each point, just check if you are able to make the string. Like at each point, just try the letters from small to big. right? Like here we tried that can we put A, can we put B? Like okay, we could put A, so we move ahead. So here can we put A? No, we can't because we have no more A's, right? Can we put B? Yes, we can put B because if we put B here, then we would have enough letters to fill right here to make S as subsequence, right? So at each point in the string, just try all letters from A to Z that can you put that letter here. Like let's say if you are checking for jth letter, then just check that can you put the letter J on this blank. Okay, so if you put letter J on this blank, then is it possible? So what does possible mean? That basically whatever is the part of the string S that you haven't made yet, you should be able to make it using these elements right here. Like you can simply create a frequency array of T. Okay, a frequency array of T which will show you that what are the letters that are remaining to be kept here. So if they have enough of the letters to make this string S, then you can actually put this letter J right here. Okay, like I'll give an example. Let's say you've already placed A and B. Okay, you have placed A and B. So until now, this string S has not been made. Like no part of string S has been made, right? And you have put A and B. Now let's say you put an element right here. Now if I ask you that can you put a B here? Can you put a B here? So what you will do is you will try. Like let's say you put a B here. So now our bag has like these letters ED and ECFC. So we will check that can we make this string DCBE using these letters. So we cannot because B are these B's are not enough. Like we have zero B's, but we want one B. So that is not enough. So actually we cannot put B here. Basically, we cannot put a B here. Okay. Then we'll try C. Can we put a C here? So yes, we'll again check that can we make DCBE. So yes, we can make DCBE using the remaining characters because there are enough of them. We have a D also, we have a B also, we have C also, we have an E also, right? So we can put C, so we'll put C right here. Then can again here, can we put B? No, we cannot because then I won't be able to make DCBE. Can I put C here? No, I cannot because then I can't make DCBE. But if I put a D here, if I put a D here, then actually you just have to make CBE from the remaining letters. From the remaining letters. Why? Because you have already made a D. Like this D can match with this D. And in the remaining letters, you just have to make CBE. Right? So you can just check that do you have enough CB or E. So you have CB and E, right? So actually you can put D here. You can put D here and then you can place, like you can put your pointer right here, indicating that you have already made a D. Like you can simply use a pointer and keep track of which elements have you already kept. So you have already kept D now. So you can move the pointer right here. Now what will you check? You will check B, right? So you cannot put B here. Why? If you put B right like this, you will still have to make CBE, but you don't have enough B's. So you cannot put B here. Can you put C? Yes, you can put C. Why? Because you already made DC right here. So you will only need BE from these four indices. You will only need to make BE and you have B and E. So simply you can maintain a frequency array of the remaining letters in S, like whatever is remaining in S to make, and whatever you have in T. And at each step, if you want to check that can you place that letter here, you can just check that do you have enough of the other characters to make the string S or not. Okay. So I hope it is kind of clear. I'll show the code as well, which will help you understand a little bit better. Like this test case maybe was a bit too long to explain. Okay, but all right. So here I just took the string s and t. Or okay, before that, do you have a doubt? I think I over explained this problem quite a lot, maybe. If you have a doubt, then like I can explain again. Do you have a doubt? Maybe you all have already solved it by yourself. Okay, so I'll show the code. So in the code we have string s and t, c in s and t, and I'll make the frequency array for s and t. Okay, so this is just the frequency array, the frequency s of s of I plus plus. Okay, and same for t. And now I'll check function. So this check function actually what does it do? It takes in the frequency array of s and of t and like checks if all the elements are less than equal to t. Like all the elements, basically the frequency of all the letters in s has to be less than equal to t. So then it will return true. And if anyone is greater, it returns false. So basically, it just checks if we can make this string s using this string t. Okay. So if initially the check returns false, then it is impossible, right? So I'll print this and return, and then I'll have my string ans and the pointer p1. So p1 indicates that from where in the string s we haven't made, right? So p1 equal to 0 means we have to make the entire string right now. So I'll run this for loop t dot size times, okay, and at each position I'll check for each character. Like I'll just put 26 length. So basically it runs from A to Z. Okay, like I'll try if I can put A, then I'll try if I can put B, and so on. So first I'll try if I can put A, or basically in the jth loop, I am trying if I can put J or not. So first of all, it has to be in the frequency array of T. Like the frequency of that has to be greater than 0, right? In the T. Like we have to have an element of that if you want to put it right here. Correct. So if the frequency of J is greater than 0, then there are two cases. Um, if that character is the character that we need in S, like let's say we already have made, like let's say our string here is ACEB, okay, and we have already made A and C, so our pointer is right here, okay, like somehow this the string T was something, and we have made, let's say ABC is there. So we already made A and C, right? And E is there. And here I am checking if I can put E or not. Like I checked for A, B, C, and D. For A, B, C, D, I checked. And I could not put them right here. So I am checking for E now. So can I put E right here? So yes, I can. Why? Like I can simply put E right here and increment this pointer. Okay. And it works. It always works. Why? Because the fact that I put C here, like the fact that I reached here, it means that I can make EB using these, right? I can make EB right here. And if I make E right here, then of course I can make B here, right? So I can simply increment the pointer. Like if my current element J, if my J is equal to S of P1, if my S of P1 equal to J, then I can simply increment the P1. right? And also just decrement the frequencies. That is, um, in the frequency array of S, I'm only storing that what I have not made. Like I won't store A and C in the frequency array, and same for T. Like the element that I have placed here, I will decrement the frequency. So I'll decrement the frequency of J in F, in sorry in T also and in S also, and I'll push back in the answer, right? And otherwise, like this if was if the next character is in this string only, right? And otherwise, uh, I will decrement this ft of j, like from basically I'll try to put it like I'll try to put e here. I'll try to put e here. So I will decrement its frequency, right? And the pointer stays here only. Like let's say not e. Let's say if I'm trying to put d. So I'll put d here. So I'll decrement the frequency in t of d. So frequency of d minus minus, and the pointer will stay here only. So in my S, I have the same frequency vector, EB, right? So I'll decrement the frequency of J and I'll check. Okay. So if um, it returns true, that is, if it is possible, then I will just append this J into my answer and I'll break. So break out of this for loop, this 26 sets of for loop. That is, we found a character. So we'll stop looping. Like we checked for A, we checked for B, we checked for C, and then we found that C is possible, so we'll break. Right. So if check returns true, we'll break. Otherwise, we will try again. And like basically we will again remove it from the string. Like here we tried D, right? We tried D, so we decremented the frequency. But now D is not possible, so we'll remove it. So we'll have to increase the frequency as well. So frequency in T of D plus plus. Okay. And then we will keep looping. And eventually we'll find out our way out. Okay. So yeah, and finally just print the answer. So this is how it works. Thank you. Um, is it clear to everyone? Like I tried to explain well, but maybe I did not explain well for some people. So if you have any doubts, then you can ask. Like any particular doubts in any part of the code, not the entire code, maybe. Okay, I'm assuming that there are no doubts. So I'll move to the next one now. All right. So the last problem of today, it was wishing cards. It is said that wishing cards on New Year's Eve can bring good luck. You have written wishing cards and plan to give them to little A. You have invited n friends to help you deliver the wishing cards. You plan to give the ith friend BI wishing cards. The friends will visit little A's house in the order of 1 to n, and each will hand over all his BI wishing cards to little A. Little A always remembers the friend who gives her the most wishing cards. So after the jth friend's visit, she gains happiness equal to the largest number of cards received so far. That is max of B1, B2 up to BJ. The ith friend can carry at most AI cards, and the total number of cards cannot exceed K. Your task is to optimally choose values of BI so that the total happiness of little a after n visits is maximized under these constraints. Note that some friends may carry no cards at all. Little a won't get mad. Okay. All right. That if it works, then Okay, it failed. So maybe it's not correct. You can debug it later. So yeah, the problem says that we have to like send some wishing cards, right? Like basically we have made k wishing cards. We have made k wishing cards, and we have n friends, right? Where n is up to 1e5. So I don't know how we have that much friends, but anyways, we have n friends. Let's assume that, and we want to send these cards to little a, right? And what will happen is like we have an array b1, b2 up to bn, right? That what is the capacity of each friend? Like the first friend can carry up to b1 cards, second can carry up to b2 cards, and so on until n. So the nth friend can carry up to n cards only, right? And in total, we have only k cards, right? So in total, the number of cards should be less than equal to k. Okay. So let's say we give b1 a1 cards, b2 a2 cards, and bn an cards, where each bi, like each ai, should be less than equal to each bi, and also the summation of ai should be less than equal to k, right? Like we gave the first friend a1 cards, second friend a2 cards, and so on. So what will happen is they will visit little a's house one by one. So a1 will visit first. I mean, one will visit first, the friend one, and he'll give the a1 cards. Okay. So little a will get a1 happiness from this. Then a2 will visit the house, and little a will get max of a1 comma a2 happiness from this. Then a3 will visit, I mean, the friend 3 will visit the house, and then from that, little a will get max of a1 comma a2 comma a3 happiness from this up to n. So when the nth person visits, we will like the little a will get max of a1 comma a2 up to an happiness from this. So the total happiness that little a gets is this value. Like if we have this array, then this is the total happiness that little a would get. Okay, and we have to find out that what is the maximum possible happiness. Like we can assign any numbers to this array, like to these a1 a2 up to an, we can assign any numbers, and we have to like ensure that ai is less than equal to bi for every I, and the total number of ai, like the total sum, should be less than equal to k. And under these constraints, we have to maximize this value. Okay, so I think the question would be clear. So we have to print the maximum value of this for any uh, a. All right. So of course, if you have to brute force this, then you can simply try all the arrays, right? But that would not pass up obviously, because the constraints are up to 10 to the power 5. So like, yeah, it would not pass obviously. Why am I explaining this? So let's think about something else. Okay. So actually, what we have is like, okay, in the final array that we have, like let's say in this test case, the final array would be what? Like 120518. This is the bi, right? So what I'm saying is the final, this is b array. So let's say the a array is 120500. Our k was 8, right? K is equal to 8. So here, this is one possibility of the array a. Okay. So each bi is greater than equal to each ai, as you can see, and the sum is less than equal to 8. Like it is equal to 8, so it is valid, right? So this array is valid. So if this is the array, then what is the happiness that she would get? So the happiness is 1 plus max of 1 comma 2, which is 2, plus max of 1 comma 120, which is 2, plus max of 1205, which is 5, plus max of these 5 numbers, which is 5, plus max of these 6 numbers, which is 5. So basically we have 20, right? So from this array, she gets 20 happiness, right? And since the answer is given to be 20 for the sample test case, this is one of the optimal arrays. Like this array is one of the optimal arrays. Okay. So actually, another way we can think about this is that this 20 is just like the happiness is the sum of the prefix max array. Okay. Like what I meant to say is that here we have this array, right? Like if this is a array and we want to find out that what is the happiness, then actually you can simply take the prefix max, like prefix max of 1 for this prefix would is just 1, then prefix max, this prefix max is 2, then max of this prefix is 2, then for this one it is 5, then for this prefix max is 5, and then for this prefix max is still 5, right? So this is the prefix max array for this A array, and the sum would be 1 plus 2 plus 2 5 up to plus 15, so 20, right? So you have 20 sum for this prefix max array, and that's why that's your score, right? So my point is that your max array, like you can think about the score as the sum of the prefix max array, right? So basically, let's say you have something not 0, let's say you have 3 here. Okay, let's say you have 3 here, then this 3 doesn't really matter. Why? Because in the prefix max array, uh, here it is 5 only. Like even if you have 3 here or if you have 0 here, it doesn't really matter, because in both cases you will get the same prefix max array, right? So there is not really a point of having 3 after this 5. Okay, that's the thing, that there isn't really a point of having a 3 after this 5, because this 5 will have the maximum until the end, unless something bigger comes after it, right? So if we have 5 here, then the only point of keeping something is would be to greater than 5. Like the only thing that we should keep would be something greater than 5 if we want to keep. Otherwise we should keep this 0. Okay, there's no point in keeping non-zero, because the answer will be same only, right? So that's the observation. Like uh, my observation is that, yeah, the observation is that in final, like in the final array, in the final array A, the non-zero elements, the non-zero elements would be in increasing order. Okay, like if you have 1 then 2, you can have 0 here, 0 is no problem, but then you have 5. So here you will not have less than 5, you won't have 4 here, because it has no benefits. So you will place 0 here. Okay, so all the non-zero elements, they will be in increasing order. Like you will not have something less than 5, or even in between also. Let's say here you won't have a 1, because then it is less than 2. In fact, you won't have equal to 2 also, because the 2 is already here. Keeping a 2 here is not giving any benefits. If you keep a 3 here, then it will give you a benefit of this 3, right? So you'll only keep the elements in increasing order. Okay. So do you guys agree? Clear till here? Found implementation hard. Yeah, that is true. Like, not that hard, but yeah. I mean, the idea is not totally like I haven't finished the idea yet. But okay, this first observation is clear, I guess, that in the final array that you are keeping, um, your non-zero elements would be in the increasing order. Okay, all right. So like if you have placed something, let's say you are placing some elements. Let's say you place one here, then zero here, then zero here, then three here, then zero, then zero. Then here you will place something greater than three only, not less than three, not less than equal to three, right? Either you will place zero, or you will place something greater than three, or greater than equal to three, right? That's one observation. So how would we use that? I will tell you about it later, how to use that. But first, let us try to think about a naive solution. Okay, like let's think about how do we solve this. So let's say if you want to find the answer, like if you want to find the answer for the array b and some value of k, okay, that in total you can have um, in total you can basically put k cards, and this is the array b, that is b1, b2, b3 up to bn. Okay, and so you want to find out the answer for this. Okay, and let's say you know the answer for up to n minus 1. Like for this array b1, b2, b3 up to bn minus 1, you know the answer. Okay, then can you find the answer for bn? Like basically if you have total k envelopes and you know the answer for this prefix for some k, like for all k from 0 to k, like basically let's say if you want to find the answer for b1 up to bn and you have 10 envelopes. Okay, and if you know the answer for this prefix for 0 envelopes, 1 envelope, 2 envelope, up to 10 envelopes, like you know all the answers, you know all of the answers, then can you find the answer for this entire thing? Like if you want to find out the answer for this thing, so either you will keep zero gifts here, or you will keep one gift here, or you will keep two gifts here, or you will keep three gifts here, and so on. So if you keep no gifts here, zero gifts here, then basically your answer would just be the answer for this prefix and 10 envelopes, right? Because you had 10 envelopes total to spend in this entire thing, and to this one you gave zero. So basically, um, you can have the answer for 10 envelopes for this prefix, and then just gives this one zero. And actually, plus whatever is the maximum that you used right here. See, if you have already the optimal array a1, a2, a3 up to a of n minus 1, okay, and you want to include an, like, okay, let's say you append 0 at the end, then in the score, actually the maximum of these would be added, right? Like if you already have 1 0 0 3 0 4, you have this array, and then if you insert a 0, then actually in the score, like initially score was what, 3 plus 6 9 plus 4 13. So for this array the score is 13, and if you append a 0 now, the score will add by 4, because in the prefix max array 4 would come here. So now score for this is 17, right? So actually to update your answer, you need the maximum value as well. So like if you want to find the answer for b1, b2 up to bn, right, for some value of k, then actually you need the answer for b of n minus 1 for all values of k, that is for all the sums. That is, you need to know that what is the total number of envelopes used, the total number of envelopes used, and also the maximum value of ai used. So if you know these two quantities, then actually you can judge that how many envelopes you can give here. Like if this is your state, this can be your state, that my dp of I j k, dp of I j and k can store that the answer or the maximum score for prefix until index I, the maximum score for prefix until index I, if I have, like if basically the maximum value that I put is j, and okay, let's not use k here, let's use l. So dp of ijl, so dp of ijl would store that what is the maximum score for prefix until I if the maximum value that I have put is j, and um, the total number of, like the total sum that I have put until now is equal to L. Okay. So this is my state, dp of ijl. Okay. And actually, since I am putting only in increasing order, the maximum value would be put at the last, right? So actually, I can say that if the last non-zero value is j instead of maximum value. But anyways, this is my state that dp of ijl would store that what is the answer for prefix I if um, my maximum value was j and the number of, like the total sum is l, then what is the answer, right? So if I want to find out the answer for dp of I plus 1, like if I want to update the dp for I plus 1, right, then actually at the I plus 1th index, okay, either I can place 0, like let's say currently I am transitioning from dp of, like okay, I know the answer till I, and now I want to find the answer for I plus 1. So let's say I am transitioning from dp of I j comma l, I comma j comma l. So I have this answer, like what is the answer for I j l, right? So if I want to transition from here, so either at I plus 1 I can keep 0, right? Like if at I plus 1, if a of I plus 1 I keep as 0, if I keep 0 here, then still the maximum would be j and sum would be L, right? So dp of I plus 1 j and L. I would get to this state, and what would its value? Its value would be dp of ijl plus uh, j, right? Because in the maximum array, like in the prefix maximum array, this j would come at the index I plus 1. So dp of I plus 1 comma j comma L would be dp of ijl plus j. If I put 0 here as a of I plus 1, or other option is that maybe I can put some value k, like I can put, or not k, let's say x. If I put a value of x which is greater than j, right? Like if I have maximum until now as j, then of course I'll put the value greater than j only here. So let's say I put some value x which is greater than j, then I reach the state dp of I plus 1 comma x comma L plus x. That is, the maximum becomes x and the sum becomes L plus x, and that would be equal to dp of ijl plus x. Because like basically if I put x here, then in my prefix maximum array x would come here because x is the maximum until, because x is greater than this j, right? So x is greater than all the elements here. So in the maximum, like prefix max array, x would come here. So my answer for I plus 1 x comma L plus x would be dp of ijl plus x, right? So either we can, like if we were transitioning from ijl, either we can keep this, or we can like put any value of ai greater than j and less than equal to bi, I mean b of I plus 1, right? So we can transition in those many ways, like the different values of x can transition accordingly. All right. So and then final answer would just be um, dp of n minus 1, and like whatever the maximum value in this dp of n minus 1. Like basically you can check all of the possibilities of the maximum value and total sum, both less than equal to k, and whatever is the maximum value, that is your answer. dp of n minus 1 comma I comma j, where I and j are both less than equal to k, right? So this is your basic dp, but actually this is not optimized enough. Like this dp works, but it's not fast enough. Okay, why? Because you have three states, right? The index, the maximum value, and the sum. So of course the maximum value and sum have to be less than equal to k, right? And the index can be anywhere from 1 to n. So basically your dp state is already n k square, n into k square, right? And if you want to transition also, like if you are transitioning, then here as you can see that for a of I plus 1, I have multiple values. Like I can choose any value which is greater than j and less than equal to b of I plus 1. So let's say if j is equal to 0, or let's say if j is equal to 1 and b of I plus 1 is k, then I would have approximately k values for a. So I would have k transitions from this state. I would have k transitions from this state. So my time complexity would turn out to be n into k cube, right? So this is actually too much, because n is up to 10 to the power 5 and k is up to 360. So n into k cube is too much. Okay. So how can I actually optimize this? We have to now optimize this dp. That's our main goal. But do you guys get this dp? that my dp of ijl is maximum score for a prefix I if maximum value is j and total sum is l. So if I have these two values, I can easily keep track of all the other things. I can calculate the new score easily. Okay, so this is the dp, but its complexity is n into k cube right now. N into k cube. So how can I optimize this? So first of all, actually we can optimize transitions. Like my point is, we can actually optimize the transitions. How? Basically, let's say I have, let's say I want to calculate dp of I plus 1, comma j, comma k. Okay. Like actually what I can do is I can iterate over this sum and this j as well. Like basically I'll do a pull dp. Here I was doing push dp, right? That from I, j and l, I was pushing the values either with ai plus n equal to 0 or with ai plus n equal to x, right? But instead of that, I'll do a pull dp. That if I want to calculate the value of I plus 1 comma j comma k, where j is a value that I have put right now. Like on the I plus 1th index, I have put j. Okay. And the sum is k. So k is basically the j plus some k dash, right? Like because the last element is j. On the I plus 1th element, I have put j. So the total sum is this j plus whatever I have behind. So j plus k dash. So if I want to calculate the value of dp of I plus 1 comma j plus k dash, what can I do? I can transition from dp of I comma something comma k dash, right? Where that something has to be less than j, right? That's the point. Like if I want to calculate, if I want to keep j here, like if I'm keeping this value j here and my total sum is j plus k dash, then I can actually calculate it. Like basically I can transition from any dp of I comma l comma k dash where l is less than j. Like see what I am saying is, let's say I want to calculate the value of dp of 5 comma 3 comma 10. That means that my last element is 3 that I have put right here at index 5, and the sum up till now is 10, right? So that means that the sum till here would be 7, right? And since I put 3 here, that means I would have put something less than that in these elements. So I have the option of dp of 4, index 4, comma 2 comma 7. Like I want some 7 here, right? So dp of 4 comma 2 comma 7 or dp of 4 comma 1 comma 7. That is, I have 1 as the maximum in these 4, or dp of 4 comma 0 comma 7, right? That is maximum is 0. So I can transition from any of these states, right? And I'll take the maximum of that. Like of course I will take the maximum of these states. So if I want to calculate the value of dp of 5 comma 3 comma 10, I can transition from either dp of 4 comma 2 comma 7 or 417 or 407, and of course I'll take the maximum of them. So I can simply take the prefix maximum of this DP and use it to transition in O of 1. Like for every um, DP of I plus 1 j, comma j plus k dash, I can calculate it in O of 1. So essentially, every state, every state I'm able to calculate in O of 1, right? So I'll be able to calculate this dB in O of n into k square now by just using a prefix maximum along this direction. Okay, like I'll make another array pre of ijk. Pre of ijk will store the maximum value of dp of I comma l comma k over all l from 0 to j, right? So I have this like prefix maximum array which stores the prefix maximum along this direction, and I can use that to find the dp value, right? So that is one optimization that brings us from nk cube to nk square, right? We can simply store the prefix max array. But now this is also too large. Nk square is also too large because n is up to 5e5. I mean n is up to 1e5 and k is up to 360. So this nk square is also too large. So how do we actually optimize that? Let's see now. So actually there is one more optimization. Like there is one observation that finally whatever your array is, finally in your array, okay, finally your array will have n elements, right? It would have n elements, right? And their sum would be less than equal to k, right? Less than equal to k, sum would be there, right? But um, the value of k, the limit on the value of k is much smaller. Like k is limited to 360 only. Like k less than equal to 360 is given, and n less than equal to 1e5 is given. So actually, if you have, let's say, n 1e5 and k only 360, so in your final array, most of the elements would be 0. Like out of this 10 to the power 5, out of these 1 lakh elements, only 360 of them, at most 360 of them, would be non-zero. Like if they all have ones, if we have 360 ones, then we can have this much sum, and but the other ones would still be 0, right? So most of the elements in your final array would be 0, right? So this n is kind of fake. Like this n is actually fake because at most k elements only in your final array can be non-zero, right? So that's the observation. The observation number 2 is that at most k elements in final array can be non-zero. Okay, right? That's one more thing. But now, so now what I am saying is, like, I have one more claim that, okay, let's say I give you two options. For final array, I give you two options 10400. Okay, this is one option, and one more option is 14000, right? 10400 or 14000. So which one would you choose? You would choose this one, right? Because this creates a better maximum array. 4 4, like 1 1 and 4 fours. whereas this one creates 1 1 and 4 4 4. So this one is better, right? So you would want to keep your elements to the left if they are same. Like if they are the same element, you would try to keep them to the left. Okay. Like for example, I'll give one more example. Let's say I have 1 0 2 4 0 0, and I have 1 4 2 0 0 0. That is, this 4 came right here. So now what will you choose? So again, this one will give you 1 1 2 4 0 0, whereas this one will give you 1 4 4 4 4 4 4, right? So this is better, obviously. So definitely, keeping your elements towards the left, keeping your elements towards left is never harmful. Like it might happen that some it's not beneficial. Like let's say if you have 2 0 4 1 0 0, or if you bring 1 right here, so you would have 2 1 4 0 0 0. Then it doesn't really matter because in both the cases it's 2 2 4 4 4, like two twos and four fours. Here also it is two twos and four fours, but it will never give you harm. Like moving some element backwards would never give you harm. Okay. So my point is that um, you would always try to move the elements backwards, right? But let's say in this notes example, here in third test case, 1 0 4. Okay, in the fourth test case, this was the input, um, 2 4 5 4 3, right? So the optimal way is 2 0 5 0 0. So why can't we do 2 5 0 0 0? It's because the limit is 4 right here, correct? So we cannot really move this 5 to the left because this limit is actually 4. Okay. So actually, we can't really move it to the back. But my point is that okay, I have a claim. I have a claim that for each element, for each distinct value of AI, you will only use its first instance. Like let's say for example, if my array A, I mean sorry BI, not AI, BI. Let's say your array B, that is the capacities, is like 1 2 3 2 2, 1 3 4 4 2, right? So there are many numbers here, but only 1 2 3 and 4, right? So what I am saying is that if you are using a 2, like if there is a non-zero value of AI at some place where 2 is there, then it would be at the first occurrence. Like rather than placing a number here, you would place that same number right here. Okay. And here you would place 0. Like there's no point in placing a non-zero number here. My point is that if you have an occurrence of 2, which is to the left, then you would not place an x here. There is no point. You would always place a 0 here. And why is that? Because you can simply place the x here, and the prefix maximum array would be the same. Like if you place an x here, then all the elements after this would become x, 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 right? But if you place an x here, then also they would become xx, right? And also it might give benefit that these ones also become x. So my point is that you would never keep an x here. You can always keep 0 here and x here instead, right? So for each element, for each distinct value of bi, you will only use its first instance. That is, for all the other positions where it occurs, it will always be 0. Like this 2, this 2, this 2, this 2. So here all of them would be 0. Only the first one can carry some cards. Then for these two fours, so this 4 will always carry a 0. Then this one would carry a 0, this 3 would carry a 0. So my point is that you can always find an optimal array which has zeros at this 6 positions. Okay, that's my entire point. That for each distinct value of AI, you will always be able to find out an answer which has zeros at all these positions where it is not the first instance. Because whatever you are putting here, if you are putting an x here, you can put x here instead and it will give a better answer. Okay, and let's say you are putting a 2 like a 1 here and a 2 here, then you would say that if I don't put 2 here, then it will change my answer. But then you can simply, instead of putting a 2 here, you can put 2 here directly. Then it would give a better answer. Like, do you guys get it? That you can always find a optimal answer with all zeros where it is not the first occurrence. So you would always keep zeros in these positions where it is not the first occurrence of this bi. Okay. I hope it is clear until here. So now it is pretty simple. That yeah, now it's pretty simple that you have only, like, basically the problem was that our time was coming out to be n into k square, right? Our time was coming out to n into k square, and it was too much because n limit is up to 10 to the power 5. But I told you that actually n is fake. N is fake because most of the entries in your final array would just be 0, right? And now we have also observed that all the all the elements which are not the first instance would all of them would be 0, right? So finally we have only certain indices, we have only some indices which are the first instance where some non-zero thing can be there, like x, y, z, right? And how many of them can be there? Basically the number of distinct numbers, number of distinct elements. Like the number of places where I can put non-zero thing would be equal to the number of distinct elements. All right, and it can be like less than equal to k, because the elements AI, the AI elements can only be up to from 1 to k, right? So the number of distinct elements can be only up till k. So actually, n is fake. So n is actually k only. Like we have only k indices where we have to check that what is the number of numbers that we can put. Like we can apply DP only on those indices, and it will work in k into k square instead of n into k square. Right? N into k square की जगह we have O of k cube, and it will work in k cube. Okay. Yeah. So the entire point is that we will only put non-zero things if it is the first instance of that bi value. Okay, like in this array, 1 2 3 2 2 1 3 4 4 2, we will only put a non-zero thing either here, 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 or here. Okay, that is the point. So to transition, actually now it is not that easy, because like let's say you have, okay, I'll take this example, 1 2 3, 1 2 3 2 2 1 3 4 4 2, right? So you have observed that, okay, here 0 will come, 0 0 0 something, and then 0 0. So like whatever you put here, like let's say you put x here, then in the max array, like in the prefix max array, this x would propagate to here and here as well. So you would have to store the answer of this as well. Like while you are just storing the dp of I, you'll have to account for these two x as well. So like you have to increment by 3x instead of just x, right? In the transition where I told you that uh, dp of, yeah, like in this transition where we are transitioning from dp of ijl and we are putting some value x. So we are saying that dp of I plus 1 x comma l plus x is dp of ijl plus x. So why plus x? Because in the prefix max array at the index I plus 1 we have an x extra, right? But actually when we are trying to do like this, that some places there are 0. So let's say if I put some value x, then in the prefix max array, the x will propagate from like at this index, this one, and this one as well. So I'll have to add 3x and not just x, right? That's the only difference that you have to take care about. And otherwise, it is just O of k cube dp. And O of k cube, if you apply the prefix sum, like prefix max approach, that is to calculate, like if you want to calculate that if you keep a value x here, that is dp of I, let's say I, x is the maximum element, and some k dash plus x, then you would have to like transition from dp of I minus 1 some value comma k dash, where this some value must be less than x. So basically you will transition from prefix of I minus 1 x minus 1 comma k dash. Okay, and basically you will add um, x into number of zeros plus 1. What is the number of zeros after this? Plus 1. Like let's say there are 4 zeros here, so in the prefix max array total 5 x's would be there, so you would add 5x. So prefix of I minus 1 x minus 1 comma k dash plus 5x. Okay, this is the correct approach. Actually in the code, like in the code I have actually used x only, not x minus 1, and that also works because um, if we have, like if I use x here, that means I am choosing less than equal to x. That is x here and x here also works, and there is no issue because in that case as well, here x will propagate. But if we transition from x plus 1, let's say, doing from x plus 1 is wrong, because if we have x plus 1 here and we put x here, then these would be x plus 1s and not x's, right? But yeah, um, I just transition from prefix of I minus 1 comma x comma k dash. Okay, so this is the case where I put a non-zero element on I, and if I put a zero element on I, then I can simply calculate dp of ij comma k from dp of I minus 1 comma j comma k. Like basically if I want uh, j, like the maximum value to be j and sum to be k, and I haven't put, like I have put 0 here, so the maximum value would come from this prefix. So from I minus 1 the maximum should be j and sum should still be k, because here it is 0 only. So the two cases are that either I put a non-zero value at index I, so I will transition it like this, prefix of I minus 1 comma x comma k dash, or if I put a 0 value at this index, then I could transition from dp of I minus 1 comma j comma k. Okay, so this is the entire solution. It was pretty complicated, to be honest. Like I don't know how so many people solve this. Let's see the rating of this. Okay, it's not opening for some reason. Okay, it opened, I guess. Let's try this. Yeah. So this was 1900. Like they say it is 1900, but it is definitely not 1900. It is definitely tougher than that, I feel. Okay. Like probably a lot of people cheated or something. I don't know. But it felt tougher than 1900. But anyways, 1800. Okay. Maybe I'm just out of practice. That's why I felt it is tougher. But yeah, I'll show the code. It is pretty complicated, but okay. So I have, like, I took the input of the array B and I'm naming it as A, and then I have marked vector. So marked means it is the first occurrence of that element. Okay, and I've set S initially empty. So if I iterate over the elements and I insert the element into the set, and if its count is 0 already, then it is the first occurrence. So I mark it as true, right? Then I have a vector of pair. Like this vector of pair basically stores the index comma value of all the mapped elements. So this V, like basically the size of this array A is n, but size of this V can be at most k. Okay, and our DP would be of like V dot size into k into k. Okay, so if V dot size is 1, then I have this edge case. All right, and then I have made this DP, this 3D vector of DP and the prefix minimum, prefix, this pre as well, which is the prefix maximum. Okay, so base case where I is equal to 0. So, and yeah, I initialize it using int min. That is not possible. Like I initialize using not possible, right? So for the first element, either I can give it 0 or give or 1 or 2 or up to like a naught, right? That's the limit. So dp of 0 comma I, like if I um, give the first element I, right, then the maximum value is also I and sum is also I. So dp of 0 comma I is just I into number of zeros after that, like basically I into the number of elements. Like let's say I know that I have, let's say, 1 1 1 2 2, like 2 3 2, right? Then this one is marked, this one is marked, and this one is marked. So these two are zeros, right? So whatever I place here x, so it will get propagated to here, so 3 times x. So I am, that's why I'm counting it 3 times. So this index 3 minus 0, right? So v of 1 dot first minus v of 0 dot first. So this is the number of elements where I have to propagate this I. Okay, and then I just take the prefix maximum also of this dp. Okay, like this dp I initialize, and then I will take the prefix maximum for the index 0. Okay, all right. So now I will take the transitions. So first of all, okay, this line is useless actually. So ignore this. I will, okay, yeah. Now int next is just the variable which stores the number of times my value will propagate, right? So next is just v of I plus 1 dot first minus v of I dot first, like the difference of the two indexes. And if it is the last one, then it is n minus v of I dot first, right? Um, then I have like two cases. The first case is where I am adding j. Okay, like this first case is where I am keeping the element j at index I. Okay, so j can be up to v of I dot second, and prev means like I am transitioning from um, dp of I minus 1 comma previous. Like previous is the last sum, previous the sum that I am transitioning from. Okay, so j plus prev should be less than equal to k, right? So basically in this case, I am trying to put the element j at index I, right? So in dp of I comma j plus prev, that's the current sum. So I'm trying to relax it with um, prefix max of I minus 1 comma j comma prev. Like here, ideally it should be j minus 1, okay, plus j, like j times the number of zeros plus 1, right? So I just try to put j here. So I transition from the prefix maximum array. So this is the first case where I try to put j on the ith index. Otherwise, this is the second case where I try to put 0 on the ith index, right? So I can, like, so here I am iterating over what is the last element. Okay. So dp of I comma last comma previous is dp of I minus 1 comma last comma previous plus next into last, right? Like that last value will propagate further. Like if I put 0 right here, let's say I am trying to put 0 on this index. So if I already have x here, so this x will propagate until here also. Or like if I have, well, let's say one more unmarked element, so x will propagate once more. So it will propagate twice more. So that's what it means. dp of I minus 1 comma last comma prev plus next into last. So basically just understand that here prev is the previous sum, like total sum until I minus 1 where I am transitioning from. And in the first case, here j is the element that I'm trying to put on the ith element. And in second case, this last is the element which is the maximum in the prefix of I minus 1. And I'm trying to put 0 here. Okay. So these are two cases. And finally, just update the prefix maximum along this direction, this second dimension. So prefix of I comma L comma j is max of dp of I comma L comma j comma prefix of I comma L minus 1 comma j, right? And finally the answer is like basically the answer is just dp of n minus 1 comma I comma j, where I and j can be anything, right? Like you can have anything as the maximum and you can use any number of envelopes. So whatever is the maximum of this value, you will print that. So actually, I already have the maximum prefix stored, right, for this. So I can just use the k. Like I'll store, like I'll use the prefix of n minus 1 comma k comma j. So I'll just have to iterate over j. So like basically what I wrote here is that prefix of n minus 1 comma k ka max element. Okay. So prefix dot back is just prefix of n minus 1 comma k, and I will find its max element, and I'll print that. Okay. Um, so that was the solution. It was pretty complicated, to be honest. No, it was rated. How to be as intelligent? Like maybe it's the result of me um, like studying so much during JE, I guess. Like basically, just keep stimulating your mind. Like I believe that if you keep using your mind and it gets stimulated frequently, then it would improve. Like it's similar to what how bodybuilders build muscle. Like they ensure they that the muscles are actually getting tired and they are getting stimulated, and so they grow. So if you're trying to solve problems which are not up to your difficulty level, like if you solve hundreds of arts of problems, like 800 problems, then your mind won't get stimulated, so it won't grow. But if you like try to solve problems which make your mind think, then I think it would get better. Does IQ matter? I think to a certain extent it does, but uh, you can reach a very high rating despite of your IQ. Like if you keep practicing thoroughly and if you are clear with your theory and you are motivated and consistent, then I think you can reach a certain rating which you would not think that you could have reached. But beyond that, it's IQ, I guess. Like that, this is the opinion of many people, not just me. Like there is someone called Arpa on Codeforces. He's also he thinks the same as well, and like many people think the same. In fact, there is one blog of Amnik where he can where he says that anyone can be anyone can become LGM. Yeah, anyone can become GM on C Codeforces. That's what he said. So like no matter what their IQ is, they can become GM. Like I don't know if I agree with it or not. I can't speak for the GMs, but I think you can easily become like expert or CM if you just practice hard enough. Yeah, even I got very confused. Like you can see that in the standings, I solved the C div to C in 7 minutes, and I took 100 more minutes to solve B. Like in fact, I had gotten the idea of like this observation number two. This observation two I had gotten at the 1 hour mark. That only the first occurrence of each element will be used, but still I could not I had to implement it. Like I was implementing it for 40 minutes or something. So it was kind of tough for me, and some masters could not solve it as well. This person who solved C1 C2 but did not solve B, so it was pretty tough. It was not 1900, I feel. But anyways, I hope this was kind of clear. Like if your DP is not good, then you should not try to solve this problem. You should first practice DP a little, And once you're confident with that, you should again watch this or try it by yourself, because I think you would not be able to understand this if you don't have clarity in DB. But yeah, I hope this was good enough. If you have any doubts, then you can ask in the comments. All right. So I'll take your leave then. Bye, everyone. Good night. Intern season. I got my intern on the first day at Rubric. So intern season ended at that day, fortunately. Like on 26th July, I got my intern. And since then I am okay. Thanks, Surat. He is a D show intern, by the way. Oh, not D. Goldman Sachs. I Yeah, Goldman Sachs, right? Thanks. Anyways, I hope you all enjoyed this. I'll see you later. Bye bye.